This is section 4 on proving triangles congruent using side, 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 and side, angle, side. So in the previous section, in order to prove triangles are congruent, we needed to show that every single side had a congruent side and every angle had a congruent angle that it was corresponding to. These are two ways that we can prove triangles congruent by only showing three things. The first one is side, side, side congruence. So what side, side, side congruence says, if two triangles have all three sides congruent to corresponding sides, then the two triangles are congruent. So what this is really saying is if we have two triangles, I'll call this one ABC and this next one DEF. If you're on ABC and DEF, we know AB and DE are congruent, BC and EF are, and AC and DF are. If we just know that, we know nothing about the angles, we only know about the sides, we can say that triangle ABC is congruent to triangle DEF by side, side, side. Okay, so if we know the three sides are congruent to each other, then the two triangles are congruent. Okay. Side, angle, side is if two sides, two corresponding sides, and two triangles are congruent, and the included corresponding angle is congruent, then the two triangles are congruent. So what this is saying is if we have two triangles, ABC and triangle DEF, so if we have two sides that are corresponding are congruent, so let's say AB and DE are congruent, BC and EF are, and then if we have the included corresponding angle, so the included angle means that the angle that lies in between these two sides, so it would be angle B and angle E are congruent. If that's the case, then the two triangles are. So we would say triangle ABC is congruent to triangle DEF by side, angle, side. Now, a good way to do this, or a way that a lot of students find this easier to look at, is you just label it. So here, it's a side and a side congruent, so I label it with an S. Angle, side. And then it tells you the acronym, SAS, side, angle, side. This top one, side, 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 side. That's a good way to look at it, and I'll tell you which acronym. So now what we're going to do is we're going to do some proofs using side, 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 or side, angle, side. And we'll do two column proofs here, but remember, if you like flow proofs or paragraph proofs, you may, of course, always use those. So prove the following. Given D is the midpoint of AC and AB is congruent to BC, we want to prove triangle ABD is congruent to triangle CBD. So we're going to have a statements column and a reasons column. And the first thing we always start with the proof is the given. We just copy that down exactly. So D is the midpoint of AC. And AB is congruent to BC. The reason this is given. Okay, then we're going to go to our diagram and label that. So we have AB and BC are congruent. And then D is the midpoint of AC. Well, if D is the midpoint of AC, that tells us that these two parts, AD and DC, should be congruent. Now notice right here we just marked some new things on our diagram that were not specifically written in the given. So that's what we're going to write down for step 2. That AD is congruent to CD. And the reason why is we use the definition of midpoint. Okay. Now, anytime you have a vocabulary word like midpoint up there, this will always end up being one of your reasons in the proof. All right, it will typically be at step 2, sometimes at step 3. But if you have a vocab word up there in the given, it will end up being one of your reasons, and you will have to use that. Okay, so now we want to take a look. We either want to show we have all 3 sides congruent, or we have a side angle side. So right now we have a side side. So we need to show that either angle A is congruent to angle C, or we need to show that BD is congruent to BD. Okay, if we show A and C are congruent, that would be side angle side. If we show BD is congruent to itself, that would be side side side. The second one's going to be very easy to do because BD should be congruent to itself because it's reflexive. So we'll write that down for the third step here. BD is congruent to BD, and the reason why, it's reflexive. If you don't remember these vocab words, you can always write a description of why. Something like, it should be congruent to itself. Right? That's kind of an obvious one. So if you can't remember the vocab word, write down the description. Now we see on our diagram, we have side, side, side being shown, so we certainly can prove the 2 triangles congruent. So that will be our last step here. Triangle ABD is congruent to triangle CBD, and the reason why is side, side, side. Now when you're doing these proofs, your last step right here, whatever step is your last step, should be whatever you were trying to prove. Okay, so your first step and your last step are always given to you up here in the problem. All right, we are going to do another proof. This time we are going to be given AB is congruent to CD and AD is congruent to BC. We want to prove triangle ABD is congruent to triangle CDB. This time we will do a flow proof. So here we go. AB is congruent to CD. AD is congruent to BC. I'm going to box that in and write given underneath it. I'm going to go over on my diagram and mark that. So AB and CD are congruent. AD and BC are congruent. Okay, and I'm going to label. I have a side, side. So I need to show one of 2 things. I either need to show that the included angles are congruent, so I need to show that angle A is equal to angle C, or the third side is, which would be BD is congruent to BD. Now in this particular problem, it would definitely be easier to show that the third side is, because notice that is the same side. So that's what we'll go ahead and show. So this is new information that we're just kind of pulling. So right here, all right, BD is congruent to BD. I'll put a box around it and write reflexive. Okay, and now I'm using both of these pieces of information, so I'll have 2 arrows drawn together. So using both of these pieces of information, we can say that triangle ABD is congruent to triangle CDB. And the reason why is side, side, side. Okay, so there's another proof that we did. We showed side, side, side. We have all 3 sides written down as being congruent, so therefore we can say the 2 triangles are. One more proof here. And this one we'll do in paragraph form. So here we are given that M is the midpoint of US and M is the midpoint of RT. We want to prove triangle UMT is congruent to triangle SMR. I'm just going to move that diagram up so I've got some space to write. So we're going to start with the given. So given M is the midpoint of US and RT, then, well, now let's label what that means. So if M is the midpoint of US and RT, US, if M is the midpoint, that means UM and MS have to be equal. If M is the midpoint of RT, that means MT and RM have to be equal. So we can say, given M is the midpoint of US and RT, then UM should be congruent to MS, and MT should be congruent to RM by the definition of midpoint. Okay, and now let's stop and take a look at what we have here. So right now we have side, side. So we either need an included angle or a third side. But this diagram has 4 triangles, so it's not clear exactly which triangles we're trying to prove are equal. So let's take a look at that closer. So we want to prove that triangle UMT, so I'll highlight that in green, is congruent to triangle SMR. Okay? So that means in order to prove that, we either need to show the third sides are congruent, so RS and UT are, or we need to show that the included angle is. The included angle here would be angle UMT and angle RMS. Now here, RS and UT, they are clearly not the same line, so we can't say that they're equal to each other by reflexive, and it would be difficult to prove. However, if you look at this angle here, we should be able to show that those two angles are equal to each other because they're vertical. So that's exactly what we're going to do. So then we're going to say angle UMT is congruent to angle RMS because they are vertical angles. So now notice that we have a side angle side labeled on our diagram, so we have enough information to prove the triangles are equal. So we'll conclude, so we'll say therefore triangle UMT is congruent to triangle SMR by side angle side. And there's our proof. Okay, so for these proofs you will either be looking for side, side, side or side angle side. And you just need to show those 3 things are congruent. Once you have shown them, you've completed your proof.